Hi everyone and welcome to this third video for Agricultural Engineering 311. So in this video we'll just start off by recapping what we've done this far. So we've looked at micro irrigation, which consists of drippers and micro sprayers, and then we've looked at the differences between the two as well as the components of micro sprayers. So in this one, we're just going to look at the difference between the two again, and then we're going to look at how to make sure that you space your emitters the right distance apart from each other. So if we're talking about drip, why would you have a drip system instead of micro sprayers? And firstly, it's because it's more efficient. So you can imagine that when you have a drip system, you only have one droplet that once at a time moves out of your emitter, whereas with a micro sprayer you have a lot of droplets that move through the air before it finally lands on the soil. And because of that, there's a lot more evaporation with micro sprayers than there is with your drip system. Your drip system is less vulnerable, so that's because you can think a micro sprayer that's connected to a pipe. It can stand around the whole tree and sometimes closer to the path or the road that's between rows in an orchard, and so a lot more damage can happen because it's closer to traffic than with a drip system that's inside the line. And then the drip versus micro depends on soil type and crop. So if you can look at a picture like this, you'll see that a clay soil versus a sandy soil. So in the clay soil, the water moves in a lateral direction more than with a sandy type of soil. That's because the clay is less permeable, so it takes longer for the water to move downwards, and then due to the capillary forces, the water actually ends up moving a lot more in a lateral direction than it does for a sand soil. Then if you look at the type of soil, so the lateral distribution in the soil determines drip versus micro. So that depends on the kind of crop you have, which one you would require. Would you require something that moves deeper down, or would you require that more lateral movement? The shape and size of the wetted profile differs. So that's, as you can see with this, just the movement of the water differs, because in clay you get that width that you don't necessarily get with the sandy soil. But as well, if you are using a micro sprayer, you can imagine that the wetted profile where the water actually lands away from the emitter is further, so it's a bigger space around the emitter that actually gets wetted. So that also depends on what your needs are for your crop. You can imagine if you have a dripper, and if you're using a dripper kind of system for a citrus tree, then you would need to run two lines on either side of the row to make sure that you have enough water for your crop. Whereas as you use micro sprayers, you'd only need to run one lateral line with your micros, then extending from that line. And that's why it's not always clear which one is better than the other. It's all the needs that you have as a farmer. And so the distribution of water is influenced by the clay percentage, the fine fraction, and the organic material. And the wetted profile should fit the root network, like you can see with this sketch. The profile in the soil depends on what you need. So if you need the wider one, and then that's the one you should try and have. And this is a similar kind of thing where it just shows you that different soils and different profiles occur in the soil, and that's also why it's very hard to get to a place where you know exactly how far you need to space your emitters from each other. And so if we look at how to do that, there's an easy test. So lay out two dripper lines 30-meter long with different emitter spacings. Irrigate for 12 hours on a loamy soil and 6 hours on a sand soil, so that's because of the permeability. And you allow the water to penetrate the soil for further 24 hours on heavy soil and 12 hours for sandy soil. because of permeability as well. And then you'll dig profiles and determine the dimensions of the wetted width. So after that 24 hours, you'll dig a profile and you look at something like this. So this is the kind of thing you'd be looking at in the soil after you've been digging your profile. And the important thing is to choose the spacing that results in a continuous wetted strip, or 80% of the wetting width. So to make sure everyone understands what that means, you have 2 drippers or micro sprayers next to each other, and you want to make sure that 80% of the continuous wetted strip is 80%. So that is what is meant by that. You want that 80% overlap, or 20% overlap. So in this case, you would want something more like A than the other 2 scenarios. And this is how you would do that. So you can see B is that distance, that radius around your emitter, and you would multiply that by 0.8 to get to how far you think you should be spacing your emitters apart. And then you can start testing it with this test of laying it and seeing with your specific soil if the calculations that you made, if that suits the spacing. And then lastly, if we look at our laterals, so this is the pipes that come from the main line, will only be important for online mounted emitters. That's where we'll be talking a lot about laterals, and includes all drippers and sprayers that are not mounted inline or internally. So that's all your micro sprayers and then your online or external drippers. Your advantage is your standard polyethylene pipes can be used, which are cheap, and a variety of sizes are available for consideration. And your inline and internally mounted emitters, drippers mounted during manufacturing, so they are more expensive.